an equal to 1 plus 1 upon n, and n is coming from set of natural, then the sum of the series, this n is from 1 to infinity minus 1 raised to the power n plus 1, an plus 1 divided by n factorial. We have to find sum of this series. Whenever we need to find sum of the series, many techniques are using partial sum technique, or directly expand this expansion and get a expression. Either few terms cancel out, or we got an expansion like e raised to the power x 1 plus x raised to the power n, or log x. These types of expansion if we got, then we can directly get the sum of the series. Here this is alternating series. So to find its sum of the series, an is given as 1 n plus 1 upon n, and expression for series is minus 1 raised to the power n plus 1, n is running from 1 to infinity, a n plus 1 upon n factorial. As a n used here, so what is a n plus 1? It will be n plus 1 plus 1 upon n plus 1. Use this in this series. It will be summation n running from 1 to infinity minus 1 raised to the power n plus 1, n plus 1 plus 1 upon n plus 1 divided by n factorial. Now distribute summation as normally we do. Summation n running from 1 to infinity minus 1 raised to the power n plus 1 n upon n factorial plus summation n equal to 1 to infinity minus 1 raised to the power n plus 1 upon n factorial plus summation n equal to 1 to infinity 1 upon n plus 1, and this factorial in denominator also. Now put the values of n. For this it will be, so you can cancel out this one, and it will become n minus 1 factorial. Now put the value of n. When n equal to 1, then 0 factorial is also 1. So 1 minus 1 upon 1 factorial plus 1 upon 2 factorial when n is 3, minus 1 upon 3 factorial, and so on. Now for this one, minus 1 upon 1 factorial plus 1 upon, first term will be positive and second term will be negative, 1 upon 2 factorial plus 1 upon 3 factorial minus 1 upon 4 factorial, and this one will be when n is n equal to 1, or you can observe what is this. This is nothing but n plus 1 factorial. So minus 1 raised to the power n plus 1 will also be there. So when n is 1, first term is positive. So 1 upon 2 factorial plus next term will be negative 1 upon 3 factorial plus 1 upon 4 factorial minus and so on. So you can see here this is negative factorial 1 and this is positive. This is positive and this is negative. So entire all these terms cancel out by this term. Only first term will remain here and this one also. So 1 plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial and so on. This is 1 and what is 8? This is e raised to the power minus 1 and minus 1 is not here. So it will be e raised to the power minus 1 is 1 minus 1 upon 1 factorial plus 1 upon 2 factorial. So these two terms we need to add and subtract. So minus 1 plus 1. So it will cancel out. So 1 plus E inverse will be our right choice. 1 plus E inverse is option D. So option D is correct option.